How are you doing, math learners? This is your free access YouTube edu creator, Math Teacher Ash, and welcome to ML with Sir Ash. For today's lesson, we're going to discuss the final part of our discussions on operations of functions. Specifically, this is about the composition functions. Well, this is kind of a challenging topic, and I'm sure you will enjoy this video. But before anything else, hit the subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners, welcome to our final topic here in Math Learning with Sir Ash regarding on the operations on functions. Now, we already have discussed the addition, subtraction, multiplication, and division of functions, and today we're going to level up the topic, and this is all about the composition functions. The first question is, what is a composition function? A composition function is basically having two or more functions, and what you are ought to do is you will input a certain function to another function. Example, if we have two functions, f of x and the g of x. Now, talking about the composition function, we have the symbol not O but a hollow dot. Okay, now if we are trying the f of g of x, so that is how we read this one, f of g of x. So the composition of f of x and g of x. Okay, so my dear math learners, in this operation, you need to be more careful. Why? Because f of g of x is different from g of f of x. Okay, why is that so? Basically, if you have the f of g of x, that means that the g of x is being input to the function of x. Again, the g of x is being input to the function of x. While in the g of f of x, the f of x will be input to the g of x. So this is the notation of the two. Okay, so what does this mean? Okay, my dear math learners. So let me give you an example. So let's say our f of x is, let's say, x plus 2, while our g of x is x squared. Okay, now, having f of g of x, what we need to do is our g of x, this one, will be substituted to our f of x. Okay, so it will give us f of g of x is equal to x squared plus 2. Get that? I'm sure you might be wondering, how did that happen, Sir Ash? Okay, so this x, that is the normal x, right? Okay, so since this x will be substituted by the whole g of x, our whole g of x is basically x squared, right? So this x squared will be substituted to this x, giving this x here as x squared. Alright? Now, how about g of f of x? Now, having this, we will have x squared, okay, as our overall function. Now, since our input here is f of x, then this x plus 2 here will be input here, okay, our g of x. So this x plus 2 will substitute the x here. So since this is x squared, that will become x plus 2 squared. So if we simplify that one, this will become x squared plus 4x plus 4 by applying the FOIL method. Okay, now I know you might be having, how did that happen, Sir Ash? Let us consider some more examples to have a better and deeper understanding on this matter. Okay, math learners, we are here with our first set of examples. The two functions given are the d of x and the a of x. For the d of x, we have the square root of x plus 5, while in the a of x, we have the x plus 2. Okay, so we are ought to find the function d of a of x. Okay, so How do we do this one? So d of a of x, that means d of a of x. Okay, so our d of x will be inputted by this one. Okay, so since our d of x is x plus 5, okay, I'll just write that one so that you can follow it. So this is our d of x, right? We will substitute our x by the a of x. Okay, so this will become x plus 2 plus 5. Get that one? So this x is being substituted by the whole a of x, and that is x plus 2. So that is x plus 2, giving us the whole expression square root of x plus 2 plus 5. And if we simplify this, we will have x plus 7, the square root of x plus 7. And that is the final expression for the d of a of x. Easy, right? Now, how about if we have the value 2? Okay, so if we have 2 to evaluate in our square root of x plus 2, that will give us 2 plus 7. I just substituted the x by positive 2. So giving me square root of 9, and the final answer for that, the square root of 9, is 3. Though some people would say positive negative 3 if we are trying to find two values of x. However, we are just trying to get the principal root here, and the answer is 3. Easy, right? Now, let us go to our second set of examples. Okay, math learners, we are now here in our second example, and we have three functions given: the c of x, the m of x, and the n of x. Now, we also have three problems to be solved: the m of n of x, the n of c of x, and the n of m of 2. Okay, so how do we solve this one? Okay, let's try first the m of n of x. So for the m of n of x, that is basically m of n of x. Okay, so our m here is this one, right? So we have 5x minus 3. Okay, our n of x is this one. So we will change our x here by this one, giving us 5 times x plus 4 minus 3. Easy, right? Now we simplify. So 5 times x, that is 5x. 5 times 4, that is 20. And then we apply or bring down our minus 3. So we have 5x plus 17. Okay. And this is your final answer, 5x plus 17. Easy, right? Now, how about our second problem? We have n of c of x. So n of c of x, that means the n of c of x. Okay, so our n here is this one, okay, x plus 4. So let's just write this one, our x plus 4, okay, our n. And then we will input our c of x. So our c of x is this one. We just put it, or we just replace it to our x here, giving us 5x squared plus 17x minus 12. Okay, that is for x. Then we just add plus 4. Easy, right? Okay, so we simplify. That is 5x squared, 17, okay, plus 17x, negative 12 plus 4, that is negative 8. And this is your final answer for this second problem. Easy, right? And now let us go to our final problem. We have the n of m of 2. Okay, so my dear math learners, let's try first to solve this one, m of 2. Okay, so we have our m here, right? So let's try to substitute this by 2. So that will give us 5 times 2 minus 3. So that is 10 minus 3. And the final answer is positive 7. Okay, so we already are correct here. Now, let's input this value to our m again. So this 7 now will be again input here. So giving us, okay, 5 times 7, okay, because our x here is now 7, right? Okay, minus 3. And then 5 times 7, that is 35 minus 3, giving us 32. So 32 is now our part here. Easy, right? Now, for our final solution, we have n of x. Okay, so our value 32 will be input in our n of x, giving us our x here will become 32, so that is 32 plus 4, and the final answer is 36. Easy, right? So I hope you got this, my dear math learners, on how to apply the composition in different scenarios. Now let us have one more example. Okay, math learners, we are now in our final example, and we have a combination of the composition as well as the subtraction of functions. So we have here three given functions, the m of x, the n of x, and the p of x, and we are owed to find the m of the difference of p minus n of negative 3. Okay, so how do we solve this one? Okay, my dear math learners, basically what we need to do here is to solve this by parts. So the first part here is the p minus n of negative 3. Let's try to solve first our p minus n of x. Okay, so that is p of x minus n of x. Okay, so our p of x is 9x minus 5, while our n of x is x cubed minus 4. Okay, so we will distribute the minus there. So that is 9x minus 5 minus x cubed plus 4. If we simplify that one, we put our highest degree, so that is x cubed, so negative x cubed, and then the next degree, which is, so since there are no quadratic term, we will go to the linear term, so that is positive 9x, and then negative 5 plus 4, we can simplify that, and that is negative 1. So this is the final answer for the p minus n of x. Okay? Now, having said that, we will now input this to our m of x. Okay, so since this is our m of x, now what we need to do is we go to number 2, right? Okay, so we have the x plus 3 as our term. Okay, so x plus 3, and then we will input this one here. Okay, we will input this one, so giving us, we will substitute x by this one, so that is negative x cubed plus 9x minus 1 plus 3. You get that, my dear math learners? The whole p minus n, okay, is being input to our m of x. Okay, so now let us simplify. So we have negative x cubed plus 9x plus 2. So now this is already the function if we are getting the m of the difference of p minus n of x. However, for our problem, we are trying to solve for 3, right? Okay, so evaluating this expression, we will substitute our x by 3. So we have negative 3 cubed plus 9 times 3 plus 2. Alright, so 3 cubed is 27, so that will become negative 27. 9 times 3, that is again 27, okay, plus 2. So negative 27 plus 27, that is 0. 0 plus 2, that is positive 2. So therefore, our answer is the square root of 2. Easy, right? So I hope, my dear math learners, you have learned how to do the composition functions in the operation of functions, and I hope you have now a strong foundation on the operations on functions from the addition, subtraction, multiplication, division, as well as the composition functions. Now, if you do have some questions about our topic, feel free to put your inquiries in our comment section below. Thank you so much. God bless. And I hope I have given you a justice in discussing this topic. This is still your free access YouTube edu creator, Math Teacher Ash. And always remember, it is fun to learn mathematics if we are together learning. Thank you so much. God bless and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.